Okay, thank you. So hello everyone. So my name is Paul, and I collaborated on the project that I'm going to show you with Tom Svilans, which unfortunately he couldn't make it today, but for the presentation. But he will be here around 2 or 3 p.m. So you will have the chance to talk with him. So first, before to talk about the project, I want to present to you about where we come from, Tom and myself. We are part of the InnoChain Research Network, which is a European program which gathers many different universities and industry partners. So we are both studying at CITA, and we have each of us have 2 industrial partners. Tom is working with the White Architects in Stockholm and Blum Lehmann, which is an important wood manufacturer in Switzerland. And on my side, I collaborate both with Bureau Habold Engineering and Design to Production. And basically, the topic that we have in common is to look at freeform timber structures. For Tom, it's obvious because of its partnership with Blum Lehmann. On my side, it's because Design to Production has been involved in the rationalization of all these structures that you actually see here. So those are all the banks and museums that Gilles was referring to. Yes, so basically to make a project like this, there is a lot of different steps that you need to take into account, from the like global design, the global network, to the full detail of one single elements. And yeah, that's the top-down approach. I agree. Okay, there is a, yeah. And so basically, design to production is sitting really in the middle. They have to deal with the segmentation of such structure, and they have to take into account structural requirements from the engineer, but also a lot of constraints coming from the fabricator, such as logistic or machine reach or waste. So we've been looking at how we could actually link all this scale together from the abstract network to a specific nodes and to the fabrication scale, and how the different scales can feed back to each other. And so those are really early experiments that was done actually before we submitted we even were aware of the Tallinn Architecture Biennale, where we could, where the user was able to draw very easily an abstract network. Then it was projected onto a master surface, and then you could have like full detail and resolution of each element. So that was expanded a bit later on, like 2 master surfaces in this case. And wood itself is a multiscalar material because if you think about it, the single fibers have an impact on how the structure will grow. And so we look at different natural ecosystems that offer many different spatial qualities. For example, this tree located in Hawaii, it doesn't, the branches don't only split, but sometimes they can merge together again. So this was quite an inspiration for the project. And so now I will talk about like the way we design the process. We started really simple. We tried to look at a branching pattern and see how we could influence it and influence different length of the different members. And then push it into 3D and map the different elements on top of it. And then finally map this pattern onto a global structure. And also, we also wanted to have some structural depth. So this required a bit of mesh processing. You had to manage the splitting in different locations and see how the member could actually connect to each other. And so finally, this is the full model of the project with the underlying mesh. And on the right, you see an abstract network which represents all the connections of the structure. And so, of course, we had to think about the fabrication. So we took a part of this monster, and then we tried to see how we could actually fabricate each element and see how they could connect to one another. And with this process, actually, we were almost able to quickly have feedback between a low level and a high level. So if in the design process we were seeing that the beam was not really behaving well, we could manually adjust the global setup and have a better output. And then we made some physical prototypes. We did some molds, and we're also involved in robotic fabrication. And for here, you can see how we made one branch. We basically just made a lot of sections with MTF boards, and then we could lay the laminates on top of it and have the final elements. And we're also looking at scanning processes and see if the digital and the physical models were coherent. As you can imagine, there was quite a bit of springback. So the figure on the bottom left, you can see the red areas, which doesn't match with the original digital model. And finally, that's our proposal. So we wanted to make two entrances, two gathering, one facing the museum and one facing the streets. So in the section, you can see here that the height is more or less like 4.5 meters, and that's our proposal. And some other perspectives from the night. And in the day. Yeah, that's it. Thank you.